Okay, well, thank you so much for coming today. It's amazing to see a full room. It's awesome to have you all here. My name's Jewell. I'm part of the product team at Incorta. I'm going to be spending the next 30 minutes or so talking about what it means to design modern analytics solutions and how, as we're designing these solutions, one size definitely doesn't fit all. And I'm going to show you this in four main parts. So we're going to take a tour through some of the last generation data architectures that I think are still very much in production today. We'll spend a little time exploring what I'm going to call some of the unseen forces that are at work in these data platforms, actually driving constant evolution in how we store, how we process, and how we deliver analytic insights to users. I'm going to show you some situations where we mustn't assume that all data problems get solved in the same way. And then finally, we'll bring it all back together and see where modern analytics could take us next.
Live or work in London.
So let's take a look at the general consensus of how most analytics projects get delivered today. We start on the left-hand side with our raw data sources. We could be talking our ERP systems, our CRM systems, and basically anything else that we need. We then take our data on a journey. So we take it through various stages of refinement. Could be starting in a raw landing zone, perhaps a data lake, and we'll see many vendors in the hall today talking about that. Maybe we take the data into a curated data warehouse, on into different presentation layers, maybe data marts, to make the data available to the business in various departments, in various technologies. At each stage in this process, data engineering decisions move the data further away from the source detail, often reshaping or remodeling that data, so that just a small fraction remains for analysis. So first, I wanted to talk to you all about how we ended up with this complex set of data silos that we use to produce our analytics. And to do that, I need to talk about evolution when it comes to technology. And we can plot this on a map that shows how just about any technology can go through a journey of four general phases that have some pretty well-defined properties. Over to the left, an idea might take its initial form for a market that is completely unprepared for its arrival. It seems like magic. Then we see our first custom-built solutions. They're often a little cumbersome, but they're there to prove that the technology could be feasible. We start to build products, maybe we sell them, maybe we rent them in the cloud, where the properties of our object become much, much more stable, and we start to differentiate based on form or feature. And then finally, our technology stabilizes, we reach a stage where it's universally recognized. So I'm going to give you a couple of examples. Let's start off with how we think electricity technology might have evolved over the centuries. Over on the left-hand side, I'm showing you a diagram of something called the Parthian Battery. Now this goes back to the Roman Empire, kind of 2,000 years ago. Potentially it was used for electroplating jewelry, no one quite knows, but basically this is where humanity and electricity started.
We've got a lot of data.
We move on to a custom electrical generator that was initially the size of a building. We go on to the powerhouse of companies like Siemens and Westinghouse, who build electrical generators for companies worldwide. And then finally, on the right-hand side, we get to the concept of the national grid, where electricity comes through a socket. We don't generally pay too much attention to where it comes from or how it's generated.
Also, as I mentioned,
do you want to talk to
part of Young, and
you're hearing two voices. Let's just check with the technical people for a second.
Across all their brands and across all their territories. And although we can provide data to them at the moment, it's not particularly streamlined. We have to create extracts.
I'll check with my technical guys. Let's see. Thank you.
And as an organisation, we need a better way of working with this data. So it was decided we need a new platform.
Folks at the back, how are we doing?
So the first thing was, well, what are we going to do? It's going to go cloud. Everyone's doing cloud, obviously.
I'll wait for a wave and then we'll get restarted.
Which platform? AWS, really simple one. We already have a relationship with AWS.
Oh, you don't want to listen to that.
Next one, database.
Can you hear me up the back? We good to go?
Options, but Snowflake made the.
All right, let's get interactive. If you can hear me and no other presentation, give me a thumbs up.
You get from
How's it sounding?
The ability to scale.
No, oh no, thumbs down.
Pretty much take our queries and just move them straight over.
Okay, let's hold a second.
To Snowflake was a winner. For our front-end reporting at KFC, we use MicroStrategy, and MicroStrategy have done a lot of work with.
Can we mic me up?
And they convinced us this is just going to work. So that was
right. Okay.
Pretty much.
Shall I lean forward?
Easy decision to make.
I'll lean forward. Okay, give me thumbs up now, please, everyone. Okay, let's do it. All right. So quickly to recap what you're seeing on the screen, then. So we go from something that was brand new to humanity, something that worked but was enormous and kind of cumbersome but proved the value. We move on to really the first products where companies like Siemens built electricity generators to sell to other companies and to rent them out. And then finally, we talk about the national grid where electricity kind of comes through a socket. We don't pay too much attention to where it came from. Perhaps we should pay a little bit more attention these days, but basically it becomes a commodity and a utility. I'll give you one more quick example, kind of on the same scale, and this is really the evolution of computing technology. So we move from Charles Babbage, his initial concepts, we move to custom-built computers after the Second World War, we move to modern laptops and desktop machines, and then finally, to the right-hand side of this evolution, we get to ubiquitous cloud computing. So once again, the ability to get and obtain computing power simply at the flick of a switch. And one compute unit is generally the same as another, whether I go to Amazon, Google, Microsoft, or others. And I'm not claiming to have invented these maps. They come from a researcher called Simon Wardley. I put a link at the top of the slides if you're interested in learning more. But researchers like Simon use these maps to show really not only how technology evolves, but also how these elements can be used as really foundations to deliver higher order value. So for example, tracking the map from the bottom, as power starts to become commoditized, it starts to become easier for compute to follow that similar path to the cloud. Once we have utility compute, we start to look at our need for storage. And this also evolves from giant magnetic tapes, maybe through to solid state drives, and once again, commoditized into the cloud. And then from all of this cloud utility comes the idea that maybe, you can handcraft a function that only runs on specific hardware. Welcome to the 1970s. But you can actually evolve this to the point where we now see serverless functions, where you don't even need to specify a machine to run your functions on. And on we go.
I sat down.
And I'm going to propose to you all in the room today, there are three major factors that we need to consider when we're looking to evolve and tune our analytics performance. And those are memory, storage, and the data models that we use to capture the meaning of the data underneath. And we'll take a look at these one at a time. So first of all, memory. Hopefully this is a fairly well-worn, well-known chart. Kind of shows the average cost of a gigabyte of RAM from 1980 on the left through to the end of the century, and it shows this enormous drop in price in the early 80s. In fact, we can actually look at a broader picture dating back all the way to the 1960s that really shows more of a logarithmic scale that memory prices tend to follow as evidence of this commoditization effect. So we start off with a colossal $5.2 billion for a gig back in 1960, good luck, all the way down to roughly $3 in 2020. And it's really interesting to start tracking the changes in analytics itself over the latter part of this chart, along with those decreasing costs. So for example, the arrival of MapReduce as a data processing framework, that was all the way back in 2004, the distant past now, but it introduced us to the era of big data. And this design for big data was still at a point where that cost of 1 gigabyte of RAM was still nearly $400. It relied really heavily on the swapping out of files using things like commodity storage inside environments like Hadoop. And when we talk about storage, we also see that it's evolved as well. One size no longer fits all. So in this room, I'm going to almost guarantee our traditional default position when it comes to working with data is to use row-based formats, things like CSVs. Why would that be?
understand.
That's probably because it's human readable, and as humans we like to be able to read this data immediately, but it's probably also the case that it's really easy to load a CSV into environments like Excel. But as storage formats evolve, so too did the idea of arranging data differently. Maybe we start to store data in a columnar format rather than a row-based format. Could that lead us to performance benefits? And this is where we start to see technologies and frameworks like Parquet and ORC starting to become more ubiquitous in recent years. So with row-based data, the theory is you read all the columns, row by row, and you pay the computational price whether you used all of those columns or not. And this is particularly painful if you have very, very wide tables in your data sets. With column-based data, you can access individual columns when you need them. So we save a little bit on performance every single time we query them by skipping over the columns that aren't required. Now, columnar format is also great for compression as well. We can store unique values only. We can hold pointers in those Parquet files to point to duplicates, meaning that a columnar data source is often merely a fraction of the row-based equivalent.
The decision was what we're going to do with.
And that takes us to the data models themselves. So if you're working with really large-scale data sets, let's say you're working with clickstream data, you work for a media company that has web impressions data, that naturally lends itself to techniques like MapReduce, where it's fundamentally a data problem. You put all of your data into a simple, single facts table, you shard it, you break it up, and you send it out for parallel processing across your cluster of machines. Now this MapReduce process really does scale brilliantly. We can go into the hundreds of petabytes if you've got enough servers, and technology around MapReduce and similar frameworks have continued to evolve with open source technology like Presto, which has come from Facebook.
If we did that, we make Atlas our primary.
But what if your data doesn't look like this? What if you're dealing with one of those big ERP systems like SAP or Oracle's e-business suite, where you end up having hundreds, if not thousands, of relational database tables that you need to traverse in order to pull the data that you need? Even a fraction of this so-called big data spread out across hundreds of tables can absolutely cripple traditional queries, can cause terrible performance problems. So it really is the case of the elephant and the mosquito in data terms. The trouble is, though, data architects seem really desperate to use a single pattern to cover both these scenarios. That same distributed query engine, the same transformations in a data pipeline, the same extraction and load processes, and the same cloud backbone. Except what you find is what works for one often results in disaster for the other. Now, one of our customers has lived this journey, a little company you might have heard of called Meta. Now, back when they were just starting out as Facebook, they'd already amassed pretty significant data volumes, and they stored them in environments like MySQL. And Facebook, of course, were innovating pretty heavily around how to process this data at scale. So we saw from Facebook's own engineering teams technologies like Hive and Presto coming from their internal teams as a way to address this big data performance. Similar companies, so you'll see Netflix mentioned here, are also adopting these technologies pretty rapidly for their own data challenges. But on the business application side, well, honestly, it's a familiar story. They ended up with performance issues. They ended up having problems closing out their books using their ERP data. They tried, and believe me, they tried, adopting a big data approach to this highly normalized data. I think at one point we got a quote, maybe it was from a data architect who'd just come off a Facebook boot camp saying, surely we can do all of this in Presto. We invented this after all. It just didn't help. So Facebook turned to Incorta to try something new, taking a legacy technology stack consisting of multiple vendor solutions built on top of their ERP system, the fundamental applications that run their business, and simplifying the whole process with the Incorta platform. And this allowed the company to close their books 5 days earlier, every single month. A huge transformation to a critical business process.
The next phase we're working.
And that leaves organizations in a much better place, really, to start selecting a data architecture that meets their needs. So whether that is a traditional modern data stack, as you'll hear from many of the talks at the event over these couple of days, or whether it's an architecture that actually solves business problems against their complex source systems. So let's head back to our map and continue our story. So if we've created utilities for our data models, our in-memory analytics, and our storage, what gets disrupted next? What starts to appear on the left-hand side of the map? Well, first of all, I'm going to contend it's the notion that we need complex data transformation pipelines in order to query our business application data. Let's take a look and see if we can disrupt that. In fact, we can almost express this disruption, simply put, don't reshape data and don't aggregate data for analysis, which really can feel like quite a challenge to probably a lot of data practitioners in the room. Remember the reason for most of our data pipelines. We move data from one place to another, we use pipelines to transform that data from complex systems into more simplified structures, things like reporting views, dimensional star schemas, and so on. And we do all of this to make the data easier to query. And we can't talk about query performance without talking about joins. So not everyone realizes this, but there are actually several different flavors of join that can be coded by engineers and run in the background of your servers or your databases. In the BI and analytics space, it's really hash joins that do most of this heavy lifting. And this is really where we need to focus if we're going to eliminate lots of this data transformation pipeline and its overheads. And actually, this is where some of the great innovation is actually happening to eliminate the need for things like hash joins that run at query time. So when data gets loaded, instead, joins can be pre-computed for all possible combinations. They can get stored in extremely efficient in-memory join indexes. Every query, in this example here, between sales and product gets served by this join index in memory without the need for the traditional join itself. And this innovation becomes really even more significant when we look at more complex multi-table joins. So once you've got these in-memory join indexes available, multi-table queries just get reduced to a few simple in-memory hops. And these hops generate and deliver really significant performance improvements over the current approach of most BI vendors with these traditional hash joins that need to scan, to probe, to build data sets at each step of the query plan. And ultimately, this can lead to real efficiency when we start to hit queries that touch 50 or 100 relational tables in a modern ERP or a CRM system, and that can drive real performance without the need for data reshaping or data remodeling. I'll tell you a story. A Fortune 500 global coffee retailer was really struggling with their data pipelines when it came to timely, comprehensive access to data from across their 28,000 worldwide stores. And this frequently led to inefficiencies. Now sure, it was always possible to analyse high-level metrics, maybe by store level, but detailed analysis, down to the individual SKUs, just wasn't available, and this led to all sorts of issues around food waste and a drop in profitability. So having an agile data pipeline that gets to this most granular level of business data, whether that's 35 billion gift card transactions or 20,000 individual product SKUs, gives a whole new level of resolution to an analysis. Having the data refreshed multiple times per day was the absolute game changer. This led directly to a 40% decrease in food production costs as a direct result of having an agile data pipeline. All of this delivered in just 10 weeks. So, we add an evolved understanding of data pipelines to our map, we can start to see changes, not only to technology, but also to working practices. So just as the evolution of cloud computing led to changes in how we handled aspects like mean time to recovery, or brought about revolutions in DevOps or CI/CD, lots of other areas as well, so too, I'm going to say, does analytics practice also change with the innovations that we've talked about. So one of the biggest forces acting on working practice right now is this real tension that exists between centralization and decentralization. Should we bring everything together in one place, or look to do work in smaller, separate units? And I think, as with most simple yes or no questions, the answer, unfortunately, is it depends. Maybe it's a little of both. Maybe unifying the data layer in our architecture and then decentralizing or composing the analytics gives us a little more freedom. Take the concept of data mesh, for example, a really hot topic at the event this week. We look to decentralize the ownership and the creation of data products into the business domains themselves. I mean, after all, who knows the subject matter better than they do? To achieve this, a unified data layer allows these experts to self-serve alongside a governance model that ensures that the right data is accessed by the right people at the right time.
Hang on. Thank you very much, everyone.
Second, take the concept of Headless Bi, and this is another emerging analytics pattern. The idea that a unified data layer can lead to a unified metrics layer that then gets consumed by a decentralized set of analytics tools. So whether that's data science, visualization, executive dashboards, this is where all the underlying metrics in each environment are guaranteed to reconcile. We unify the data, and then we compose the analytics where it best makes sense. Another story for you, this time with Nortec. Nortec, as an organization, manages tens of thousands of products, millions of connected systems. But they were also, as a business, acquiring new products, new business lines on a really regular basis. And this tied up resources into keeping their enterprise data warehouse up to date and structured correctly. And despite all of that constant change, what Nortec deployed was an agile data pipeline that could really respond to change by the domain experts themselves. So they took 2,000 of their SKUs and repriced all of those within just 16 hours in response to some global trade issues that were really starting to affect customers and suppliers. A 75% decrease in total cost of ownership. New acquisitions for Nortec integrated into the pipeline 40% faster than before, taking just 6 weeks from inception through to delivery. And to rework that familiar story from the world of analytics, we can also map the evolving analytics practices along the lines of descriptive, diagnostic, predictive and prescriptive analytics. Fairly familiar terms, I hope, to lots of you in the room, but each building from a foundation of capabilities laid out by that previous discipline. So what does the map tell us about where we should look for this next disruption? Well, I'm going to say for most organizations, folks in the room today, I think there is a slow movement away from lower levels in this map, away from maybe what's considered a perceived comfort zone when an organization gets into a groove with its dashboards and with its reports. And I'm going to say there's even an addiction of sorts when it comes to building ever more intricate dashboards to communicate ideas, but it never really moves the business beyond entry-level questions that it needs to answer. So I'm going to suggest adopting the mantra of being good enough, and I'll explain that again in the form of a map. So we'll start off with a good base of fast and accurate self-service analytics. We can quickly start to build dashboards and reports that give us answers to questions using our historical or our operational data. That is good enough. Where we need to look for evolution is with the question, why? Why did this result happen? Why was our metrics this month not what we expected? And this quickly starts to evolve our analytics practice into moving into diagnostic analytics that offer even better insights, and especially operational insights that can arrive in near real time. Now, a lot is bandied around about what real time means. For most businesses, data arrives overnight. Near real time means 15 minutes, means 10 minutes, means 5 minutes after the transaction was loaded into a source system. And this really keeps that culture of high value analytics moving forward rather than just stagnating in underwhelming rear view analysis. In Broadcom's case, they took an incumbent BI technology stack, they had lots of enterprise data complexity, and that meant that serving new insights took 3 to 4 months when a new report required integrated data from Oracle or their other business applications. So by implementing an agile data pipeline with Incorta, Broadcom really turned their stack around without needing to increase their IT headcount for things like operational reporting. Refresh times for that data dropped to a fraction of their former numbers. Queries that used to run in hours now genuinely run in seconds. But what else changes as a result of this newfound agility? I'm going to say it's not just speed, it's also the culture in an organization. Moving and struggling from 400 slow queries a day, if you're an analyst, to being able to answer over 70,000 business questions a day instead. In fact, as a result of deploying Incorta, deploying agile data pipelines, Broadcom got a huge transformation in responsiveness, data availability, 96 refreshes per day, instead of just praying that overnight load completed. But again, it's also about total cost of ownership. This new ability to ask questions, to get near instant answers by going direct to business application data, meant a heightened focus on their bottom line, dramatic reduction in maintaining legacy technology stacks and the resources needed to maintain them. So, my parting thoughts for you all. Keep a really close eye on evolving evolution within your organization and the technologies that you use. Pay really close attention to what happens as those capabilities become ubiquitous, they become commoditized. Understand that one size doesn't fit all when it comes to analytics. Explore alternative architectures really early on. Third, plan for disrupting forces that are going to affect your data pipelines. They're going to affect your analytic practices as a result of these forces. And then finally, modern analytics means thinking beyond the dashboard. Think about higher value capabilities that are actually closer to your users' needs. So if you're curious about different data architectures, maybe you're struggling to squeeze performance from your ERP analytics, or whether you're thinking about whether we need yet another data warehouse, come over and chat to us, booth 732. We'd love to tell you more about Incorta, how we can address your data challenges without all of those heavy data pipelines. Check out a demo or get hands-on with your very own cloud trial. So thank you for listening. Happy to take any questions.